Hi, calculus. Okay, so same with lesson 8.5. I'm going to go through the homework of lesson 8.6 because I think it'll just be kind of an easier way to understand this material. So there's one thing that I want to tell you before I go in here. Let's look at the directions here. We're given the vectors u equals -6, 4, and v equals 3, -2. If you're given a vector v that's in the component form, this is called the component form, AB. This can also be written as AI plus BJ. If I remember correctly, this is kind of more the physics way to do it, but I just wanted to give you that information so that you know it. Okay, let's find the dot product. Here we're given u times v. Well, if we're going to find the dot product, let's say that u is written as AB times, and v is CD. Well, this would be equal to A times C plus B times D, all right? So let's actually find the dot product of UV here. We're going to have -6, 4 times 3, -2. So that's -6 times 3 is a -18 plus 4 times -2 is a -8. That equals a -26. Okay, that was simple enough. I think you can do number 2 on your own. Let's find the magnitude of u squared. The magnitude of u squared is going to be equal to, hopefully you remember this from our last assignment, it's going to be equal to -6 squared, the square root of -6 squared plus 4 squared, and that whole thing will be squared. So I'm going to go through way more steps than is necessary here, but you're going to have 36 plus 16 squared, which of course equals the square root of 52 squared, which just equals 52. All right. U times dot product, it shouldn't be times, it's dot product. U dot product of 3v is equal to, this is going to be -6, 4 dot product 3 times 3, -2. So then we have -6, 4 dot product 9, -6. So that's going to be -54 plus a -24, which equals a -78. All right, let's do number 5. We are given find u times v, given that the magnitude of u equals 6, the magnitude of v equals 24, and the angle between u and v is pi over 3. Okay, well, we need to know some information about that. One moment. And we actually have a formula that can tell us that. So if we know an angle, the cosine of theta is equal to the dot product of u times v over the magnitude of u times the magnitude of v. And another way to write this would be that the dot product of u times v is equal to the magnitude of u times the magnitude of v times the cosine of theta. Okay, that's known information about angles between vectors. So we can use this information to actually find this. We know that u times v is going to be equal to the magnitude of u is 6 times the magnitude of v is 24 times the cosine of pi over 3. Well, that's going to be equal to 6 times 24 is 144. Cosine of pi over 3 is 1/2. So this is equal to 72. All right. I think that this problem initially looks really complicated, but as you do it, it's actually pretty easy. Okay. Here we want to find the angle theta between the vectors. We're given v equals 3i plus j, w equals -2i plus 4j. This is what I was talking about earlier with the I and j. So I like to rewrite them as 3, 1, and as -2, 4, just for my peace of mind. So I can use that formula that I used up here to find the angle theta. So we know that we need to know the magnitude of v is going to be 9 plus 1, so the square root of 10, and the magnitude of w is going to be 4 plus 16, which equals radical 20. Okay, I'm not going to simplify that right now because I just don't think it's going to do me any good at the moment. And we need to know the dot product. V times W is equal to 3, 1, negative 2, 4. So that's going to be negative 6 plus 4, which equals negative 2. Now we can use that formula. Cosine of theta is going to be equal to negative 2 over radical 10 times radical 20, which equals negative 2 over radical 200. And this is what I would put in my calculator so that theta is equal to cosine inverse of negative 2 over radical 200, which is about 1.7127 radians. Okay? Sounds good? So for this one, you're going to do almost the same thing, but you need to actually find what's the cosine of pi over 6, sine of pi over 6. So u is going to be equal to, cosine of pi over 6 is radical 3 over 2, sine of pi over 6 is 1/2, and v, cosine of 3 pi over 4 is negative radical 2 over 2, and sine of 3 pi over 4 is radical 2 over 2. Then you can use the same information, or use this information to do the same type of thing that you did with number 6. All right, let's turn it over. We want to determine whether the given vectors are orthogonal, parallel, or neither. What does it mean if they're orthogonal? Orthogonal just is another way to say perpendicular. Why is it? Okay. Orthogonal means perpendicular. It's the vector way of saying that they're perpendicular. And they're orthogonal when u times v, u dot product v is equal to 0, they are orthogonal. Orthogonal. And just as a point of information, when u and the dot product of v is less than 0, we know that we have an obtuse angle. An obtuse angle. Angle? I'll just say an obtuse theta. That's just a point of information for you. Now, let's do 8 here. So u is equal to, you know how I like to rewrite this, 3, negative 6, and v is equal to 2, 1. So let's find out if they're orthogonal by finding out if our dot product is equal to 0. So u dot v is 3, negative 6 dot 2, 1. So we're going to get 6 plus a negative 6, which equals 0. So this is orthogonal, or these are orthogonal. All right, let's do number 9. We're going to use our dot product again. So u dot v is equal to 4, 3 dot negative 8, negative 6. So we're going to have negative 32 plus a negative 18, which equals a negative 50. So it's not orthogonal. Not orthogonal. So what is it? Well, we actually can see that v is equal to negative 2u, right? So since it's a scalar multiple, it is parallel. Okay? Therefore parallel. I should say therefore. And I don't need this little dot here. All right. Number 10, we're asked to find the projection of u onto v. That's part A. And B, the vector components of u orthogonal to v. Okay, so what does that mean? If we are asked to find the projection of u onto v, we have a formula for that. The projection, it's written as the projection of u onto v is equal to the dot product of u and v over the magnitude of v squared, all of that times the vector v. And this is equal to the component vectors. Okay, so our component vectors, so let's say that our vector u is equal to w1 plus w2. Well, these are our component vectors. These are our component vectors. And this projection is equal to w1. Therefore, w2 is equal to u minus w1. Okay? All right, this will make more sense as I do it. Let's find the projection of u onto v. So our projection of u onto v is going to be equal to the dot product of u times v. So we have 7, 9, dot product of 3, 1, over the magnitude of v, which in this case is going to be the square root of 3 squared plus 1 squared squared, all of that times v, 3, 1. So this is going to be, whoops, I don't know why I did that. 7 times 3 is 21. So we're going to have 21 plus 9 over, that's going to be 9 plus 1, square root of 10, quantity squared is 10, times 3 comma 1. So that equals 30 over 10 is 3. 3 times 3 comma 1. So this is equal to 9 comma 3, right? That's equal to our first component. So now we can find our second component. W2 is equal to U, which is 7, 9, minus W1, which is 9, 3. So this is going 7 minus 9 is negative 2. 9 minus 3 is 6. So we found the component vectors. These are the component vectors and the projection of U onto V. Okay? I'm going to let you do 11 on your own. I think it's very similar, but instead of V, V will be your U, W will be your V. That's the only difference there. All right? Let's do our last problem here. Your car is being towed behind a truck using a force of 350 pounds. The chain attached to the towing device makes a 24-degree angle with the roadway, horizontal. How much work is done to tow the car 5 miles? Okay, so let's say you've got your car here. And it's being towed by this tow truck. I know, here's our tow truck. And this angle here is 24 degrees. And the force is 350 pounds. Okay? How much work is done to tow the truck 5 miles? Okay, well, we've got a formula for work. The formula for work is equal to the magnitude of the force. I wrote 5. The magnitude of the force times the distance. Okay, so this is the magnitude of the force times the distance. Okay. You can also think of this as the length of the projection of the force onto the vector times the length of the vector. Okay. So what's that actually going to look like in this problem? Well, we're using a force of 350 pounds, so we're going to have that, times the chain attached to the towing device makes a 24-degree angle with the roadway. Well, that's this chain here. We need to actually calculate that as well. We need to compute that in. So we're going to use our cosine of 24 degrees. Okay? And then we're taking times our distance, which in this case was 5 miles. So I put all of this in my calculator, making sure that it was in degrees and not radians. And I got that our work is approximately 1,598.7045 miles per pound. Okay? All right, that's it. We've done most of this homework as well, so hopefully you understand everything. If you have questions, leave them in the comments. I really hope I get to see you soon. Stay healthy and safe. Miss you. Bye.